Okay, let's see. Consider this. We have these two vectors, A, that you see here, and B. We are adding them up with the tail-to-tip method. So we have the tail of A here, that's A, and then at the tip of A we place B, and we get the sum by joining the tail of A to the tip of B. That's my sum, the resultant, R. Okay, now note this. The x component of A is going to be here. The y component, we'll worry about the y component later. The x component of B is going to be here. They are both represented here. This is the x component of A, and that's the x component of B. You notice that they are along the same direction, so we can find their sum by just adding them up, like here. Okay, notice it is already written, but that sum coincides with the x component of R. This is my R. The x component of R has to be that much, which is this. So in other words, we can find the x component of the vector sum by adding the sum of the x components. So I can get the x component of the resultant by adding the x components of the vectors in the sum. Similarly, think about the y component. Let me change the color of the pen. Okay, now the y component of A is this, which is here. The y component of B is this, which is here. When we add them up, they add up to this, which is the y component of R, which is this much. So the y component of the vector sum is equal to the sum of the y components of each of the vectors. Now in this particular case, all of our vectors are in the first quadrant, with both of their components pointing in either the positive x direction for the x components or the positive y direction for the y components. Now let's look at this in terms of the simulation. Okay, you have three simulations there. I'm going to pick up the middle one. I have it expanded a little bit here. In here we are shown the resultant of these three vectors. Again, let's look at their angles. Remember, these angles are not given relative to the positive x direction. They are given just, this is 52 degrees, this is 34 degrees, 34.5, and this is 34.1. Okay, now let's remove the angles. Let's look at the magnitudes. Okay, if I add the magnitude, 4.53 plus 376 plus 6.09, that's not going to add up to the magnitude of that R. Okay, let's remove these. So these, just in case, we check the tail-to-tip method. So I put one, I put the next one, and then I put the third one. And lo and behold, when I take this, it is the sum. Okay, now with this vector R, it's very hard to see, but there is the x component a little bit in light blue here, and then the y component, same color as the y-axis, but it's very tiny here, so we barely can see it. Now AX and AY, you see them there, BX and BY, CX and CY. So for example, if I'm going to add the x components, so I'm going to focus on ax, then I'm going to add to it bx here. So at the tip of A I'm going to add b, and then I'm going to put here to find at the tip of B I put cx, the tail of cx. Notice that corresponds from the tail of ax to the tip of cx, we find rx. Similarly, we can do the same thing with the y components, tail of a sub y. So I'm going to put at the tip of a sub y tail of b sub y, and then at the tip of b sub y I'm going to put the tail of c sub y. Notice here we don't have much left, that's why we see that the r sub y is very tiny here. Okay, that's the way we are actually adding x and y components of vectors, and through those we are finding the sum of the vectors. Okay, so in summary, to add vectors algebraically, we need to find the x and y components of each vector in the sum, first thing. Then add the x components separately and the y components separately. Then we'll find the magnitude of the sum by using the Pythagorean theorem. Now this is, we are going back here. If I know this and this, in our case it's going to be Rx and Ry. To find R, I use the Pythagorean theorem. That's what we are talking about. And then what we need to do is to draw the resultant vector on a coordinate frame and then use trigonometry to find its direction. For example, let's go back here. So we are going to know by now Rx and Ry, and we have the equation here that we can use, where here this is Ry and this is Rx for our case. So what we need to do is first draw a coordinate frame like there, xy, draw our vector, our Rx and Ry. Now you need to pay attention, of course, to the sign. Let me here anyway to help look at more complicated cases. Let's assume that Rx is positive. So this is my Rx, and let's assume Ry is negative. So this is my Ry. So let me change the color here so we can see things. So this is my Ry. So my R is this one here. And the angle that we get is going to be this by using this equation. So to find the angle relative to the positive x, we do 360 minus that theta we calculate. Okay, so that's the step. So again, to summarize it here, personally I prefer using tables like we see here. So all the vectors involved in our sum, we have them in rows, and then at the bottom we have our vector sum. So we have a column in the table for x component and a column for y component. So we find a sub x a sub y, b sub x, b sub y. Find the sum, r sub y and r sub x. Then we can find the magnitude of r by doing the Pythagorean theorem. And we find the angle, the direction for r, by using the inverse tangent. That's the way we add vectors algebraically.